Hi everybody, I hope you're having a great day. In this very brief tutorial, I'm going to take you through the classification of matter, just the elements and compounds. Okay, my second video after this, I'll talk about homogeneous and heterogeneous mixtures and then methods of purification. So we're going to break it up a little bit. So when you look at the OpenStax Chemistry 2nd edition textbook, all right, there's this awesome flow chart that we're going to use in the videos here. Now, this will help you determine if you have an element, okay, which is a pure substance, or a compound, which is a pure substance, or if you have a mixture. And if you have a mixture, what kind of a mixture? Now, for this video, you will need to have your periodic table at the ready. I told you to go to ptable.com and print that out. And you'll want to bookmark this page in the OpenStax Chemistry textbook. Please look at the description in the video below if you don't have the OpenStax Chemistry textbook. All right. Elements. Now, what are elements? Elements, simply put, are defined as a substance composed of only one type of atom. Not one atom, one type of atom. Many of these, as we have seen, are familiar with us. For example, gold pictured here, carbon, which is burning, pictured here, aluminium, which is pictured here by this aluminum can. Take a look at your periodic table. It actually does say aluminium. I'm not making this up, all right? So make sure you spell aluminium with a little extra I there. Copper, we're familiar with copper pennies, and oxygen. If you're alive and breathing, you are breathing oxygen. Compounds, simply put, are defined as a substance composed of two or more atoms, different types of atoms, okay, that are chemically bonded to one another. It's not just a mixture of two different chemicals. The chemical particles or substances are glued to one another in a chemical bond. Now, for example, salt, as we've seen, is made of sodium and chlorine. Those are two elements, okay? Sugar is made of three types of elements: carbon, hydrogen, and oxygen. Look at that crazy molecular formula, C12H22O11. All right, that is a compound. All right, let's talk a little bit more detail about the elements. We've got our periodic table, and we're going to be writing some stuff here, okay? So pay attention. Now, there are three types of elements in the periodic table. Elements are made of atoms, okay, which are small indivisible particles. We'll get more into detail about that later. Now, poly means many, di means two, and mono means one, all right? So let's take a look at this. The polyatomic elements are located on the right side of your periodic table, all right? And they include phosphorus and sulfur. You need to memorize phosphorus and sulfur, all right? I've boxed them up there on this little figure. Now, selenium and carbon are also polyatomic, but that's usually much less talked about in general chemistry, so we're not going to get into that, all right? So let's look at phosphorus. Phosphorus is a cluster of 4 phosphorus atoms joined together, okay? So it's a crazy looking thing, and it has the formula P4, all right? Sulfur is a cluster of 8 sulfur atoms, and that's structurally joined together as a ring, okay? Kind of like a crown, actually. You could probably wear it if you had a big enough model to fit your head. So that's sulfur. Sulfur has the formula S8 when it's elementally found, all right? Diatomic elements are conjoined twins, you could think of them, okay? They come in units of 2 that are chemically bonded to each other, and this is how these elements are found in nature. They just naturally occur as diatomic elements. So you've got a few there, all right? And I'll give you a little clue how to memorize these, but hydrogen is H2, nitrogen is N2, oxygen is O2, fluorine is F2, chlorine is Cl2, bromine is Br2, and iodine, you guessed it, is I2, all right? Now, an easy way to memorize these elements is with this mnemonic, Brinkelhoff. Brinkelhoff almost sounds like a student maybe that's a classmate of yours. Brinkelhoff, Brinclhof, all stand for the elements bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. All right? Now, if you look at the formula for bromine, we see Br2. There's a little 2 that's subscripted. It's a little bit lower down on the bottom right. The 2 indicates that we have 2 atoms of bromine, and we can see that in this little figure here, okay? So these elements are diatomic, and for whatever reason, we'll learn later why, they appear as diatomic elements, okay? Now, pay attention to the definition here. These are still elements because they're composed of one type of atom, okay? Br2 is composed of bromine and bromine. Since it's the same type, we still call it an element. Now, if anyone ever asks you what is the formula for hydrogen, you're going to tell them H2. You're going to know right away because you've learned that hydrogen is a diatomic element, and even though it says H here on the periodic table, we know that hydrogen is diatomic. I've highlighted, and you've printed this periodic table out now, I've highlighted the polyatomic elements, phosphorus and sulfur, in orange, and I've highlighted the 7 diatomic elements in yellow. So you want to highlight or mark up your periodic table as you see fit. Now, an easy way to remember the 7 diatomic elements is, as I mentioned, Brinkelhoff, but a second way is that it kind of makes the number 7 in the periodic table if you look at the pattern. Okay, you got hydrogen, then nitrogen, oxygen, fluorine, and then chlorine, bromine, iodine down. It kind of makes like the number 7 on the periodic table. Okay? So again, feel free to highlight and mark up your periodic table to help you remember these elements. One of your assignments, if you're taking my class, is to scan a picture of your periodic table and show me that you've been working on this and highlighting your periodic table. Monoatomic elements, what are those? Well, those are atoms, those are substances that are composed of just single one unit, repeating one atom units, and that's everything else in the periodic table. So if it's not those elements we've talked about, you guessed it, it's monoatomic. So what about copper? What about gold? Well, those are monoatomic. How would we write the formula for copper? We would just write capital C, lowercase u, which is the elemental symbol for copper. The same is true for gold. Gold has a symbol of G, wait a minute, Au. What? That's because Au is Latin for gold. Aurum, A-U-R-U-M, is Latin for gold. So sorry, it's not in English or your native language if you're in a different country watching this video. So it's also monoatomic, so we just write Au. We don't have a number after that. Now, as of the making of this video here in 2022, there are 118 elements that have been recognized by the international scientific community. Your periodic table will be an extremely useful reference to help keep track of them all, and who knows, maybe our periodic table will grow and expand over the years, over your lifetime. Thank you very much for watching. I hope you have a great day, and please thumbs up, like, subscribe to my video channel. Thanks a lot.